All right, so let's start with the first objective of the syllabus. And this one is to talk about the sets of numbers. Sets of numbers. Just take this, move it down here a little bit. And the objective of this lecture, I'm going to put it over here and I'm going to write it in green. I'm going to just make this a little bit smaller. Right, put it over here. And the objective is to distinguish among sets of numbers. Right? Let's start by talking about the first type of number that you will be accustomed to, a number that you're introduced to as a child, which is called the natural numbers. Let me just put this in black so it'll be different, so it will know its notes. So we're going to talk about the natural numbers. Now, the natural numbers, as I said, is a number that you're already familiar with. In its simplest form, it's the counting numbers that you encounter when you're a child. So natural numbers are the simplest numbers used for counting. Right? Now, this is usually denoted by a double struck n, and then the numbers are as follows. So you'd have 1, 2, 3, and so on and so on. Next set of numbers that we will have is the set of natural, so natural, and then we go to whole numbers. All right. This includes the set of natural numbers and the number 0. So 0 is a concept that will be introduced with natural numbers. So in primary school, you get accustomed to the natural numbers, and then once you get 0 inside there, you're starting to talk about whole numbers. So whole numbers is a double struck W that you would use to represent it. So you'd have W there and there. And let me write it a better way so you can see that. So we got there, here, and there, here. So a double struck W, and we'll have the 0, the 1, the 2, the 3, and so on. Or another way you can write it is that you'll have whole numbers. Whole numbers is equal to the number 0 combined with natural numbers. Right? This is the symbol for union. This is the symbol for union, and we'll talk about that a little later when we start talking about sets. Now, once we're done with whole numbers, we're going to talk about integers. So the next set of numbers after the whole numbers is the integers. Right? And this is the set of whole numbers. Well, I should say is the set of positive and negative natural numbers and 0. So if it is that you want to use a symbol to denote this, we'll use the symbol Z, and it's a double struck Z now. So just think of N on its side, and it's the set of all the negative numbers going to -3, -2, -1, then you have your 0, then you have your 1, you have your 2, and you have your 3, and so on and so on. It keeps going like that. So this is an example of the set of numbers that you're going to have. Or what we can also say, the integers, let me write that better. The integers is the set of whole numbers along with, or the union with, your negative numbers. So you have your -3, -2, -1, and that's it there. All right. So you can think of it as the union between your whole numbers and the negative natural numbers. After integers, we have to talk about rational numbers. Rational numbers. So we have RATI1. These are the numbers that can be expressed as fractions, right? Then you have your double struct Q as the symbol for this set of rational numbers. So you'd have Q with some brackets at the end of it here with a little tail like that, and that's a double struct Q. Let me do it a little better. So you have a circle with the Q, and then you do some brackets from the top to the bottom of your Q, so it looks like that. Anyway, so as long as you can write your rational number, or as long as we can write a number in the form of P over Q, such that P and Q are integers. Oopsie, ERs. And also that Q is not equal to 0, then we can call that a rational number. So let me show, for example, 3 is considered a rational number because I can write this as 3 divided by 1. 2 is a rational number because I can write this as 2 divided by 1. 1/3 is a rational number as well. However, the square root of 2 is not a rational number because I don't know what number divided by what can give me the answer for square root 2. And the term that we use for this type of number is irrational. All right, so if it's not rational, it's irrational. Okay, so I'll just write a little note here about irrational numbers. Rational numbers. So these are the numbers that cannot be expressed as a simple fraction. Their decimal forms are non-terminating. And if you don't know what non-terminating means, it is just simply means that it doesn't end. And non-repeating, meaning that it doesn't repeat at any point in time. The pattern of numbers doesn't repeat. For example, 0.33333, so on and so on and so on, that's non-terminating. But the 0.3, the 3 is repeating itself so that it is repeating. So that's not an irrational number, right? So when we talk about irrational numbers, I already gave you one such as square root of 2. And then we have pi, which is the next really big irrational number. So we have pi as the next really big irrational number. If it is that you want a symbol for it, you would use the symbol Q bar. So you would have your Q that you just write for rational, and you'll put a bar over it, which means that everything that belongs outside of the rational number set. So as I said, if it's not rational, it's irrational, right? Next, the next set of numbers that we have is the real numbers, and this is the one that you're going to start working with a lot more often now. So this is all the rational and irrational numbers, right? It's a combination. In the set of real numbers is a combination of both of them. So the symbol for real numbers is going to be R like this, and we're going to have Q here, which represents your rational numbers, Q here, which represent irrational numbers, combining with or union with the set of irrational numbers. Right? Let me just put a little Q. Let me write that over. Q, and then put the bracket here, and then the bracket there. As you can see, I always have lots of problems with this. Right? So Q. Bah. Right? So it's the union or the combination of all of the rational numbers. And now let me just do a little bit of a summary, since that is the last one that you're required to know, right? So a little bit of a summary. We have the set of natural numbers, which is a subset or is a part of or completely belongs to the set of whole numbers, which is again a subset of the set of integers, which is a subset of the rational numbers, and the rational numbers is a subset of the real numbers. So this is the relationship between each one of the different types of numbers that we were talking about before. Now, the other types of number sets that we're supposed to talk about is things such as factors, multiples, square numbers, even numbers, odd numbers, prime numbers, and composite numbers. Now, you would have done these types of numbers in primary school, but I'm just going to go through it just quickly enough so that you'd be able to remember it. Okay, so let's talk about factors. So factors, and we will say that these are numbers that divide another number exactly, right? So if we want an example of that, just write that. If we want an example of that, let's say we're looking at the factors of 6, then we have the two types of factors. We have positive factors, which are 1, 2, 3, 6, and we also have the negative factors, which are -1, -2, -3, and -6. Next, we have the multiples. And the multiples are simply the products that you're going to obtain by multiplying the integer by the number. So these are the products obtained by multiplying a number by integers. Okay, so let's say, for instance, an example, we want to find the multiples of 3. So example, multiples of 3. If we want to find the multiples of 3, we will just simply take the integers, which is -1, -2, and so on, and then multiply it by the value of 3. So the multiples of 3 is going to be as follows. It's going to be the set of, well, every number before that. So we have -9, which is -3 by 3, and then -2 by 3, which is -6, and then -1 by 3, which is -3, and then we have 0, and then we have 3, and then we have 6, and then we have 9, and so on and so on. Right? And those are your multiples. Now, a little key point here that you can notice: 0 multiplied by anything is basically 0. So 0 is the only multiple of every number. Right? So 0 is the only multiple of every number. Next one we have is square numbers. Just put that there, square numbers. These are the numbers obtained by squaring an integer, right? So for example, if we have -1 and we square that, we're going to get 1. Let's say we have 1 and we square that, we're going to get 1. If I have -2 and I square that, I'm going to get 4. If I have 2 and I square that, I'm going to get 4 as well. All right, so just follow that pattern and you'd realize that negative numbers multiplied by negative numbers is going to give you a positive number. After square numbers, the next number that you have to remember from primary school is the even numbers. So even numbers, and these are numbers that are divisible by 2, or, and I'll just put this or in another sentence, or these are the multiples of 2. All right, so your even numbers is basically your multiples of 2. As long as it's a multiple of 2, it's an even number. Next, we have the odd numbers. Odd numbers, and these are all the numbers not divisible by 2, or what we can say is the leave a remainder 1 when divided by 2. Another way we can say it, or any number that is not even is an odd number, right? So this here, odd and even numbers, they are usually called complementary set of numbers. So odd and even sets are complementary sets. You can check up what that means if you're not sure what complementary means. It's good to find out what the meaning of words are that you don't know sometimes. The next one we're talking about is prime numbers. Prime numbers. These are numbers greater than 1 that have no positive divisors other than 1 and itself. Right? So it's only able to have 2 possible divisors. So the examples of prime numbers, your prime numbers would start from 2. So you have 2, then you have 3, and then you have 5, and so on. Each one of these numbers can only be divided by 1 and itself. And because of that, 1 is not prime. 1 is not prime. Because the set of numbers that you can divide 1 by and not get remainder is just simply 1. Right? If it was 2, the set of numbers that you would have is 2 and 1. So 1 and itself. Same thing for 3, same thing for 5. But 1, it's divisible by 1 and itself, which is just simply the same thing, 1. So it's not considered prime. Right? Then the next one that we have is composite numbers. And these are numbers greater than 1 that have more than 2 positive. These are numbers greater than 1 that have more than 2 positive divisors. Right? So something, for example, let's say 4. The set of numbers 4 can be divided by, without leaving a remainder, is 4, 2, and 1. So this is composite because it has more than 3. Let's say about 6. 6 has the following. 6 has the following. It has 6, 3, 2, and 1. So it's also considered composite. Right? And these are the things that you have to know about for the first objective of the syllabus. All right? Thank you, and I'll try and do the next video very soon.